Okay, so let's begin our third lecture. So the application protocol that we're going to look at is basically the HTTP protocol. So I know everyone's familiar with this, but let's kind of get everybody on the same page. So basically, I'm sure everybody has used the World Wide Web. Obviously, I wouldn't be able to take this online class. So just to kind of make sure we're all on the same page, a web page consists of different objects that have to be sent um, from the server to the client. The objects can be an HTML file, uh, a Java image, a JPEG image, a Java applet, an audio file, etc. So it's basically the power. The real power of the web is the fact that you have the ability for these independent multimedia objects where you can send a video, you can send audio, you can send a picture, you can send a text, you can send a program. And they're all basically objects that can be sent through the same application. That's kind of revolutionized how people use computers. So basically, from the application protocol point of view, the web page consists of a base HTML file that gets loaded, and that base HTML file has several reference objects that have to get passed. How they do that, there's two different methods of how that happens that we're going to talk about. And each object is addressable by a URL. So the first part of the URL is the actual host name, which has to get interpreted by the domain name system into an IP address, and then the path name. So, and you look at the Wireshark Lab, and we go through this, you will see all of the all the different objects that get passed, and they all have a slightly different URL because they all have a slightly different path name. There's one for each particular object, and basically it's a location in some folder on the host where the object resides. So let's talk a little bit about the concept of how the HTTP protocol works. HTTP stands for Hypertext Transfer Protocol, and that's what's used. That is basically the web's application layer protocol. It uses the client-server model. So your client is basically your web browser, whether it's Internet Explorer, Firefox, Google Chrome, that requests and receives and displays the web objects. And that client is going to connect to some web server where the objects are going to reside, and that web server is going to respond to requests. So you basically have a server, and it's going to receive a request from a client and provide a response back and forth to that client, whether that client is a PC running Firefox or an iPhone running Safari. They're all going to use that protocol. Okay, so HTTP uses TCP. Remember, we're talking about we're sending data, so and the data can't be garbled. So we need a reliable transport protocol. So HTTP uses TCP, and it uses the well-known port 80. So it goes to port 80 on the server. The server accepts a TCP connection from the client. and HTTP messages are exchanged between the client and the server, and then the TCP connection is closed. So HTTP is known as being stateless, so the server maintains no information about past client requests. So this is different from, say, a database server or a file server, um, where you have the client state is important because the client could be making some modifications to data, and if the system crashes, you kind of have to keep track of that. That doesn't really happen in the web server paradigm. Although the web server can be a front end to a stateful server, such as a file server or a database server. There's two different types of HTTP connections, non-persistent and persistent. Non-persistent, you only send one object over TCP connection, then the connection is closed. And so in order to send multiple objects, you have to have multiple connections. And a persistent connection, multiple objects can be sent over a single TCP connection. So here we have a step-by-step example that we can walk through of a non-persistent HTTP connection. So let's say you have a URL, someschool.edu/somedepartment/home, and in that particular directory there's different objects. There's basically text and 10 JPEG images. So to get everything you want to, you need to download basically 11 different objects. So step one, the client initiates a connection to the HTTP server. So it obviously, you're basically going to type in that URL. It's going to get translated into an IP address to the domain name service. And the client automatically knows it's going to initiate that over port 80 because it's a well-known port. The server is listening on that port. It accepts the connection. Let the client know that the connection's been accepted. Then the client sends a request into its TCP connection socket, indicating that the client wants some object. The server receives a request and sends a message into that socket that's been set up. And we're going to talk about sockets a little bit more later on. Just kind of keep that in mind. That's one of the disadvantages of a top-down approach, is that we'll talk about things at a higher level, and then we'll get to more details later on in the class. Then after the object's been sent, the server closes the connection. So when the client receives a response, it displays the HTML file, and it realizes as it opens up that HTML file that there are additional reference objects that it needs to go get. So now it's going to set up a separate TCP connection for each of those objects. So next thing we want to talk about is the round trip time. That's the time for a small packet to travel from the client and server and back. So if you look at the little diagram here, you have your client. I'm going to initiate a connection, send it to the server, and the server sends it back to the client, and you have to wait. The client is waiting at that round trip time between the time it initiates the connection and gets the response back. Once it gets the response back, it can request the file, and then the server sends the file, so you have an additional round trip time from the time you request the file until the time you start to receive the file, and then additional time goes by as the file itself is being transferred. So obviously there's some additional response time compared to persistent, because you have to set up a connection. So basically, looking at the timeline, you have 1 unit of round trip time, whatever that value is, to initiate the TCP connection. 1 round trip time value for the request, and the first few bytes of the HTTP response to return. Then you have the time it takes to transfer the actual file. So to go from the initiation, from the initiation of the connection to the time when you completed receiving the file, that time is 2 round trip time units plus the file transmission time. And obviously those numbers will vary, obviously, based on the distance between the client and server, the traffic on the network, and how large the file is, obviously. So because of that, you can obviously see that persistent HTTP is a little bit more efficient. So basically, there's 2 round trip times per object, since you have to initiate and get a response back for each connection. You also have more operating system overhead for each TCP connection, because the operating system has to actually set up and break down that connection every single time you send an object. And browsers often open parallel TCP connections to fetch referenced objects. So a lot of times it's done in parallel rather than in series, to kind of save a little bit of time. So once you know you got 10 objects, you can obviously open up 10 parallel connections, but you still have that additional round trip time that you have to wait, and additional overhead of maintaining multiple TCP connections. In a persistent HTTP, the server leaves the connection open after sending the response. So messages are sent over the same open connection, so there's less connection setup overhead, and the client sends requests as soon as it encounters the reference object. Doesn't have to wait and send another request again. So you have as little as 1 round trip time for all of the referenced objects, instead of having 2 per object. So here's an example of an HTTP request message. So if you are looking at this via Wireshark, so actually we're probably not going to have the Wireshark Lab as a weekly assignment for HTTP, but I can probably add that to the additional material. But if you were to do the Wireshark Lab for HTTP, this is the type of information you're going to see. I'm not going to get into all the detail of the definition of the header lines. I can add that to the additional material. I just want to talk to this briefly so we can get on and discuss all of our application layer protocols. But basically, there are 2 types of HTTP messages: a request and a response. Everything is in ASCII, so it's easy to keep track of traffic and diagnose any issues because all the messages back and forth are in human readable format. But basically you have some commands, get, post, or head commands are common. So that's the first thing is your request line with your actual command. So you usually start with a get, where a client asks to receive a particular HTML document, and you define the type, the version of HTTP that you're using. In this case, it's 1.1, and every line has a carriage return line feed. You define the header line, define the host. You define, and there are different parameters. Like I said, we're not going to get into the particulars in this particular slide, but I will give you information for further reading. For different parameters that are defined in the header line, usually kind of defining the browser and defining basically some data definitions for the information that's going to be transferred, so the browser knows how to display information on the screen to the end user. Things like the language that's being used, character set, etc. And then you have a carriage return line feed that indicates that the header line is complete. So basically, you have your request line, which basically says what the command is, the URL, what version of HTTP. Then you have your header information, and then a carriage return line feed that separates that from the actual message data that's being sent. So there's two different ways to upload. There's the post method, and in the post method, the web page often includes a form input, and the input is uploaded to the server in the entity body. Then there is the URL method that uses the get method, and the input is uploaded in the URL request line rather than in the entity body. The method types available vary based on which version of HTTP that you're going to use. Most folks use HTTP 1.1 as a minimum, but the older 1.0 has the get, the post, and the head method. HTTP 1.1 has those methods, and additionally they have the put method that allows you to upload files in the entity body to the path specified by the URL, and the delete method that allows you to delete a file specified in the URL field. So after you send the request, you receive a response back, and there's different types of status codes that come back from your request. This one is an OK, which means, yeah, I can send you the data. There are header lines defined in the response message as well. I'm not going to get into the details of that right now. And then finally, the actual data is sent. So here's some common status codes. So when the server sends data back after you made a request, hopefully it's going to give you a status code of 200, which is okay. That's saying, yeah, I can give you the information, and the information is inside that message. 301 means move permanently. That means that data is not on the directory on the server that you specified. Here is a new location that you need to go to. Bad request basically means, hey, you gave me some garbled information. 404, which we're all familiar with, is that document is no longer found on the server. And then 505, you're trying to use an HTTP version that is not supported by the server. So let's say you're assuming 1.1, you're going to an older server that's assuming 1.0, you may get that message back. So here's a message. It was an example. This probably, with modern security, probably may not actually work anymore, but this is an example. It's in the book. So maybe you can set this up on, say, a computer on your own local network. So in this particular example, you're going to use Telnet to a particular web server, and you're going to open up the Telnet connection on port 80, which also happens to be the HTTP server. So that means you're basically setting up using Telnet, but basically setting up a connection to the HTTP server on that particular host. Then you can actually set a GET request to that host at your command line, and you can get a response using Wireshark. So supposedly, because this is used for this class, this should actually work. I haven't tried it out, but like I said, if you have a couple of hosts on your, on a local network, a couple of laptops and a router, you can try this on your own and see if that works. Another important part of HTTP is the use of cookies. So like we've said, basically HTTP and web servers are basically stateless. So cookies provide a little bit of state information that can be used to provide information and save information about HTTP connections. And I think right now we're going to take a little bit of a break. So we are going to stop here.